Hi guys, this is Miss Patterson. Today we are doing Mod H Unit 1, Lesson 1, Lab. This is the big lab. This is not the mini lab, so don't confuse it. Today we're going to be comparing buoyancy. We will calculate density of liquids and solids, compare the densities of different solids, and relate buoyancy to mass, volume, and density. So without further ado, first thing you're going to do, consider the size, shape, mass, and density of different objects that float and sink. Which factor determines how buoyant these objects are? So, what determines if something sinks or if something floats? I'm going to go ahead and give you 10 seconds to answer that. Alrighty, and then you're going to examine the 4 solid objects your teacher has given you, rank them from lowest to highest buoyancy, or with what levels each one would float. So, I have a tomato, I have a screw, I have tweezers, and I have an eraser. So, for me, I think the tomato would float the best, and the screw would be the most likely to sink. And so that's what I think. You can switch it up. It doesn't have to be what I put. I'm going to go ahead and give you 10 seconds to answer that. Okay, then we are going to get the mass of this graduated cylinder. So as we do that, we are going to select the smaller graduated cylinder, use the balance to measure of the mass of the cylinder. So I got this big one here, and then I got the small one here. So we're going to take the small one, go ahead and put it up here. As you can see, it is too heavy. So I'm going to go 20 grams, still too heavy. 40, still too heavy. Gonna go to 60. Oh, now it's too light. So now we're going to go back to 50. See if that helps. Nope, still too light. Going back here. All right, so now it's going to be 40 something, and we know that. So now I'm going to go halfway. 45. Nope, still too light. Going to go to 49. Nope, too heavy. So I'm going to go back. Let's go 48.5. Gonna go back a little bit because it's still wavering. Let's see. Alright, so it's still wavering. It's too heavy. Alright, so it is going to be 48.4. 48.4. Alright, so we're going to go over here. We're going to go ahead, let me focus in here. .4. All right. So now we're going to go, and then don't forget the grams. Grams. Okay. So now we're going to slide down here, and it says carefully pour 10 milliliters of water into the graduated cylinder and place it on the balance and record the mass. Volume in the table below. Subtract the mass of the empty cylinder from the mass of the cylinder with the water, so you can get the mass of the water and record it below. So we're going to go ahead and the mass of the cylinder is going to be 48.4 grams all the way across because it's just the mass of the cylinder. It doesn't have anything in it yet. Now, with the mass of the liquid and the cylinder, so I already measured out 10 milliliters of water. So now I'm going to pour that in here. Okay. Alright, so as you can see, it's gone up. I left it at the 48.4 and it's gone up. So now I'm going to try 60 again. Alright, so it's not 20 grams heavier, so we're going to go back to 50. And that's too heavy. Or I forgot to put the ones back. There we go. Alright, so 50 it is. 50 is just enough. So now we're going to go back. Let's try 55. Still light. Let's try 57. Alright. It's too heavy. So, once again, we're going to go back. Back. Okay, and that's going to be 56.5. 56.5. So, with the cylinder, we're going to be 56.5 grams. Now we need to get the mass of the liquid. So what we're going to do is 56.6 minus 48.4. I'm going to give you a minute or a second for that math. Go ahead and think about it. What you should get is 8.2. Okay? 8.2 grams. That's the difference. Okay? So, and then the volume is 10 milliliters, and it's going to be 10 milliliters for corn syrup and for vegetable oil. So we're just going to go all the way across there. Now you're going to calculate the density. The density, as said up here in number 5, is calculate the density of the water by dividing mass by its volume. So, the mass divided by the volume. So, 8.2 divided by 10. Go ahead and figure that out. What you should get is you should get 0.82. Alrighty, so now I'm going to pause the video and we're going to continue with corn syrup. Okay, so I went ahead and I did vegetable oil first just because it's easier to get out of the cylinder, and we'll do corn syrup last because obviously it's syrupy and sticky and everything else, so it's going to take a minute. So anyway, once again, I did 10 milliliters of vegetable oil. So now what I'm going to do is I'm going to go ahead and once again I'm going to try and see what's too much. Alright, so 50 is good. Let's try 60. Alright, 60 is still too heavy, so we're going to go back to 50. Now let's try 55. Okay, so now I'm going to go to 57 like we did before. Okay, that's way too heavy. So let's go back. Let's see where 56 lands us. Alright. Still too heavy, so we're going to have to keep going back. Let's go back. Let's try 55.5. Okay, still a little bit too much. Let's try 55.3. Okay, maybe not, maybe too light, so let's try 4. And that looks like it. Alright, so the mass of the vegetable oil is 55.4. So let's go back here. $55.4. Okay, so therefore, once again, you're going to take this value minus this value, and you're going to get your mass of your liquid. I'm going to give you a second to calculate that. What you should get is 7 grams even, because that's the difference between 55 and 48. And then once again, what you're going to do is you're going to take your mass of liquid divided by your volume in order to get your density. I'm not going to answer this for you. You should do this on your own. The main reason why I did this first column together is just so you could see how it works and do the stuff that you need to do. So go ahead and get the density for that while well, first of all, let's transfer this. Over here. Because I'm goofy, and apparently okay, and then you're gonna put it here because I accidentally did vegetable oil for corn syrup. Okay. Alright, so now I put the corn syrup inside the cylinder, and now we're going to go ahead and move this. So we're going to assume that it's at least 50 because that's what the other been. So it's going to continue to be 50 because it's heavy. Alright, so now what we're going to do is we're going to move this just like we did before. Let's get to 55. Still too heavy. Let's go to 58. Oh, still too heavy. Let's try 59. All right, so now it's just a little bit too light. So let's go back a little bit. All right, that looks perfect. So it's going to be 58.7. 58.7. So once again, we're going to put here 58.7 grams. Put grams on this one. Once again, you're going to take this value minus this value, and you should get that value. I'm going to give you about 10 seconds for that. What you should get is 10.3 grams. And then you should get the density down here. Once again, you're going to take this divided by this. And once again, I'm not going to give that to you because you need to calculate it by yourself. Okay, so, and then you're going to pour all those liquids into the big cylinder, okay? So I already poured the water and the vegetable oil in. Now I'm going to go ahead and I'm going to put the corn syrup in there. It's going to take a minute, so I'm going to pause. Alright, so everything has settled. So I know it's kind of hard to see, but you're going to see 3 layers. So here's the corn syrup, the water, and then the vegetable oil. Okay? So this is what you should be seeing at the end of this experiment. So obviously, instead of drawing a picture like your lab says, I want you to go ahead and I want you to tell me which one is the densest and which one is the least dense. So, well, I hope you enjoyed the lab. Email me anytime. Let me know if you have any questions. Thank you and have a great day.